Today we're going to review part of the homework for this week. It's going to be dealing mostly with percentages, right? Percentages, and then a little bit about interest as well. So we're just going to go through some of these real quickly. Okay. So percents are the result of expressing numbers as a part out of 100. Okay, that should be pretty clear there, right? Now, when you're expressing anything as a percentage from a decimal, you're moving two places to the right and you're attaching a percentage sign. And vice versa, as the next one will show us. If you're given, right, a percentage, you'd move it two to the left here. Okay, now, if you have a sales price, right, and let's say it's $100 and it says 20% off, all you do is multiply the discount rate, you turn it to a decimal, 0.2 by the original price, 100, to get the amount that is taken off. That's the discount amount. So if I said 20% off 100, it would be 100 times 0.2, and then we would see the discount price there. If it asks how much afterwards, you can do it two ways. You can do that 100 times 0.2, subtract it from the original amount, or you can take the original percentage, 20%, subtract it from 100 to get 80%, and then convert that to a decimal to multiply the cost by. So 0.8 times the original price would give you the price after the discount. Okay, so in the case of fractions as percentages, right, all you want to do is do the division. So if I divide 1 by 9, let's actually go to a calculator very quickly here. Right, 1 divided by 9. Okay, I'm going to get 0.1111. All right, I have to move it 2 to the right to get a percentage, and it still asks you to round to the nearest hundredth. You have to pay careful attention to these instructions when you get to the monetary amount, because some of them are going to ask you to round upwards no matter what, and others will ask you to round to the nearest cent, and it's variable. So you have to pay attention to that there. Okay, 11 over 80, exactly the same thing, right? You divide 11 by 80, you get 0.1375. You move the decimal 2 to the right to get the percentage point. Okay, same thing here. Moving it 2 to the right to get 581% from 5.81. So if you see something like that, it can be over 100, right? If it were 10.81, it would be 1,081% when you move the decimal place 2 to the right to get the percentage. Okay, same thing when you're converting to decimal. You're going 2 to the left, so 42.4% just becomes 0.424, and it may ask you to round. You just need to pay attention to that. Okay, now this one right here, if you were to convert 10 and 7/10, the first thing you want to do is think of it as, okay, 10.7, right, if you actually do. So you have a 10.7%, and then you would move it 2 to the left to get 0.107. Now, this one, 3 is 40% of what? The easiest way to actually do this is to set up a factor, right, where you compare two items. So 3 is 40% of what? Okay, so what we're going to do is put 3 over x, right? So that's going to be one thing. And we're going to say that equals, got to go back up here and tab it, 40 over 100. Okay, so 3 over x equals 40 over 100 in this case. You set it up as a proportion. Then you cross multiply. 3 times 100 is 300. 40 times x is 40x. So you're going to get 40x equals 100. 300, excuse me, I'm sorry. 40x equals 300. And so when you actually do that division, you divide 300 by 40 to get the answer, 7.5 there. Okay, there are other ways to do this. That's the easiest way to see. Figure out, okay, 3 is 40 as x is to 100, right? That's the easiest way to do those kind of proportions. All right, use the percent formula to answer the question below. What percent of 2.5 is 0.5? So what you want to do is put the part over the whole. So 0.25 is a part of 2.5. So let me get back to the calculator here. So if we put 0.5 over 2.5, and you could do this a couple different ways. You could write the fraction and then reduce to get 1 over 5, right? You're going to get, if you did it by hand, you would get 1 over 5, right? If you turn 0.5 into 5 and 2.5 into 25, 5 over 25 is 1 over 5. 0.2, we need to turn that into a percentage, so we move it 2 to the right to get 20%. Okay. The local sales tax is 5%. You purchase a car for $21,400. How much tax is paid? You just multiply 5% as a decimal to $21,400. And you multiply it by the decimal form, 0.05, to get the tax paid. Right? 1,070. Then you add that to the purchase price to get the total cost. Okay, so that would be $22,470, right? So pretty simple calculations there. Okay, an exercise machine with the original price of $760 is on sale at 8% off. The discount, you just multiply 0.08 times 760, and then you subtract that to get the sales price. So you just have to determine, is it a discount or not? Okay, now we're getting to some more complicated things. Interest. For simple interest, I equals PRT, where P is the principal, R is the rate, and T is the time. Okay, so if you're given, let's say, principal, then you're going to have to divide the interest by rate and time. So you can manipulate this equation just a little bit here. Okay, now here's another equation you're going to need to know. This is the future value. A is the future value. And I put it over here on this right here. All these equations are here. Right? The future value after a set time accruing interest is principal times the sum of 1 plus the rate times the time in years. Okay, so if it were 3 years, it would be a 3. If it were 6 months, the T would be a 0.5 for half a year. If it were 3 months, it would be a 0.25 for a quarter of a year. So T is in years, and if it's in months, it has to be expressed as a fraction. The rate is simply the interest rate as a decimal. Okay, so 0.04 would be 4%. Okay, so if $3,000 is borrowed at 5.2% for 4 months, the loan's future value, is this true or false? The future value can't be smaller than the initial amount. So when you look at that, you can just tell, oh, it's got to be $3,052 accrues, since it is accruing interest. But if you actually wanted to calculate that, we're just going to plug it in very quickly. So we've got I equals, 4 months here, right? At 5.2%. This is simple interest. It's not compounding interest in any way here. It's just simple interest. So I equals PR2. So we've got the principal, which is 3,000, times 0.052 for 4 months. That is a fraction of a year. So how much of a year is it? It's 1/3. So we need to divide 0.052 by 3. Okay, so that would be 3,000 times 0.052 divided by 3. This is just giving us the interest, right? That's it. It's telling us how much interest is accruing. If we wanted to actually see the future value, we could plug it in this. But you'll notice what we're really doing is adding this to principal if we distribute. Because when we distribute that, we get A equals P plus PRT. So you could do that either way. 3,000 plus 3,000 times 0.052 divided by 3. And that would be 3,052. Okay, so future value is always going to be larger than the initial value. Okay, principal P is borrowed at simple interest rate R for a period of time T. Find the simple interest owed for the use of the money. We don't need to worry about the days in a year yet until it gets compounded. So it would be 6,000 times 0.02 times 1 to get 120. Okay, Same exact thing here. You're just plugging in 0.08. You've got 9 months, so you have to multiply by the fraction 9 over 12. So this one, I'm just going to show you real quickly. To find the amount of interest, would be the principal 6,000 times 0.08. It has to be in the decimal format. And then times, and I'm going to put this in parentheses, right? 9 over 12, or 3 out of 4. So if you multiply those together, that's 0.75, right? You get 360. And it says round to the nearest cent as needed. This is exactly the same thing. You're plugging it into for the value of A, right? So you'd be plugging it into this equation right here. This time you have T is 2, okay? All right. Same exact thing, simple interest rate. You're trying to find the initial investment here, so you're solving for P, right? So you would have A to fill in, and then you would have 1 plus RT, and then you would divide A by 1 plus RT when you solved it to get P, right? So pretty straightforward stuff so far. And this is exactly the same kind of thing. You'd be converting the 3 months to 1/4 when you go to multiply it. Okay. This is just asking you to manipulate how to solve for P. All you do is divide A by 1 plus RT. All right, we're finally getting into some compound interest here based on how long or how often it accrues. So N is how often interest is accruing in a compound fashion per year. So if it was semi-annual, it'd be twice a year. If it was quarterly, it'd be 4 times a year. If it was monthly, it'd be 12 times a year. So N is the number of times it occurs per year. And this is how you would solve for principal to figure out, principal when you have all those other variables. Okay. In order to start a small business, a student takes out a simple interest loan, $3,000 for 6 months at a rate of 10.25. This is once again going back to the simple interest calculation, right? The PRT. So you're using these two. You don't even need the compound one yet. Okay, you're solving for A eventually. So the interest is just I equals PRT, and then you're adding that to the initial, right, to get the future value, which is A. Okay. This one, you're solving for interest rate. So same thing, right? You're plugging it in, solving for interest rates. You're dividing by the other variables. More simple interest rate. We're going to just go past this. Okay, once again, simple interest rate, I equals PRT. We're going to keep going because these are all exactly the same. All right, now this one. If a smoker spends $25 a week on cigarettes, how much is spent in a year? All you do is multiply by the number of weeks in a year. 52 times 25 is 1,300. Now, how much would be saved if you invested this money in a savings account with a 3% rate for 1 year? So all you do is plug 1,300, that's the amount, right? I equals PRT. So we go, okay, P is 1,300, R is 0.03, T is 1. We're going to get 39 when we actually solve that. We add that to the initial value. So these two equations are the same. It's just a matter of adding the interest to the initial principal to get the future value there. So you could plug it into either one of those. Not too challenging. We're about to get into more difficult things though. Okay, so this one, you need 4,000 in 18 months. So that is A. That's the final value, right? So if you were going to plug that in, it would be going in here, right? A right here. Okay, let me close that. Okay. So how do you calculate how much of a payment will go towards interest? So if you have a debt of a certain amount, you multiply that by the interest rate to find out how much interest you would pay per year, right? This is the yearly interest rate. Then you divide it by 12 because there's 12 months in a year. And that would be how much interest you're paying every month, or at least the first month, right? Now, 900 is irrelevant. That's the size of your monthly payment. It doesn't matter for this. For this calculation, you need to know the total amount, the interest rate per year, and then you divide it by 12 because the interest will be split evenly between those 12 months until you start to pay down the principal. Okay, and this is going to be the first compound interest that we're doing, so we have to use a different equation for this. It's almost the same, but this time you have the n value in the equation. And since it's quarterly, that means it's 4 times a year. So n is 4. So let's go over here real quickly. We are using this equation, right? So the principal we put in, 1 plus the rate in decimal form divided by the times per year it compounds, to the power of, right, the number of times it compounds times the number of years. So here we have 3 years, 4 is n, 0.04 is the rate. So if I wanted to solve this, right, okay, I would have to say my principal. So A is what we're solving for, equals 6,500 times 1 plus 0.0, got to make sure I do it right here. Yeah, 0.04. Okay. Now, it's quarterly divided by 4, okay, to the power of 4 times the number of years, which in this case is 3. Right? Okay, so to the power of 12 when I actually solve that there. So when I solve this in the middle, right, I'm going to simplify it just a little bit. You can do this easily on your calculator. You're going to get 60. I'm going to put this down, sorry. 6,500 times 1.01 to the 12th power. Okay, so you actually want to do that in your calculator. So what you do is you put 1.01 to the 12th power, you multiply it by 6,500 to find the future value, which would be 7,324.36. Now notice it's saying round to the nearest hundredth, okay? And then the interest, the way you find that interest is just subtract 6,500, the principal, from that final value to find the amount of interest that was accrued. Okay, this is much the same thing. You set it up in exactly the same way, except it is compounded daily. So n, as it says here, is 360. So you have 10,000 at 3%, where 360 times in 17 years, right? So you would plug in there 10,000 for P, right? R would be 0.03, N would be 360 to the power of 360 times 17. You definitely need a calculator to do that one. So you're just plugging it in there. Don't be confused by the large numbers. It's going to come out to 16,652.56. And then to find the amount of interest, you just subtract the principal from that. Okay. Now we are getting into compound interest. Okay, this, you can use the equation we've been using. You would have to plug it into all of these. A shortcut, if you're working with like just homework, you know, that's not part of a quiz or anything like that, instead of plugging every single one into this equation, you can plug it in to a compound interest calculator and it will work. Okay, so the compound interest calculator, you put in your principal, your rate, and then you say exactly quarterly, 360 per year. Sometimes the daily is 365 per year. The time in years that you're going to do it, you plug all that in. It will calculate it for you, and it gives you the equation that you would be using right here. Now, the one thing I want to emphasize, if you're doing continuous interest, the equation will change, okay? If you're doing continuous interest, right, when it actually converts over there, it will use a different equation, right, where A equals P times E to the RT power. Okay, that's for continuous interest. That's a little bit different. But otherwise, it uses the same formula that we've been using for all the previous ones. You just have to do it more. So N is going to change in all of these, right? N is the difference. Semi-annually is twice a year, quarterly is 4 times a year, monthly is 12 times a year. Continuously, you have to use E. So A equals P, E RT power. So let me get back to this. So normally you would be using this equation for compound interest. But when you have continuous interest, you have to use A equals P times e to the RT. E is the natural growth. It's the anti-logarithm, right? It's the opposite of ln. And it's about natural growth, continuous growth, okay? So you just use your calculator button for that, right? Rate is still in decimal form, not in percentage form, and time is still in years, okay? So that is the difference. When you see continuous interest growth, you know you got to use E. Okay. You'd like to have 77,000 available in 15 years. So 77,000 is going to be A, not P, because that's the end account. Account A has a rate of 4.5% compounded once a year. Account B has a rate of 4% compounded daily. How much would you have to deposit? So you're trying to find P, the initial investment there for 360 days a year. It only matters for the daily interest. For the once a year one, you're using N as 1, right? So that's a very simple equation to do. So we are plugging it into this, but we're trying to solve for P. So in that case, P equals A divided by the whole sum, 1 plus R over N to the NT power. So you would plug those in for there. Hopefully you can see where those would go. N would be 1 for the 1 year. It would be 360 in both of those cases for the compounded daily, right? Unless it said 365. It will tell you always. Okay, this is the most complicated equation, payments. Okay, PMT is the regular payment amount per month when you need to repay a loan of P dollars that's paid N times a year, right, over T years at an annual interest rate R. Okay, so this is the hardest thing to do. You can just look up a payment calculator as well. So if you go over here, payment calculator, loan amount, loan term, interest rate. It's going to use exactly that equation, but you can also do it in a calculator. You just need to know N is the number of times per year, T is the time in years, R is the rate. Same exact thing, it's just more complicated because you have to do it in the right order. So first you have to do things in the parentheses, R divided by N. Then you would also do that here, right? You try to solve for this, then raise it to the power, a negative power, and then subtract that answer from 1. So it's easiest with a graphing calculator. Okay, this contract stuff was really difficult. You might just want to review this, kind of memorize it. 2 types of contracts with a lease are a closed-end and open-ended lease. I don't know how much this is going to be actually on there. The resale value of a car is what's left over. It's the residual value after a lease. So the difference between buying a car and leasing a car is there's a lower down payment for a lease, and at the end of it, you just walk away and you don't own the car, right? So really, the residual value will affect whether you pay something or not at the end of the lease. But either way, you're not going to wind up with the car. Okay, there are 2 components of liability insurance. So this is asking about types of coverage here. So anytime someone is injured or killed in an accident, right, that is covered by bodily injury liability. The thing that covers damage to other cars is the property damage liability. Now, if the insurance is going to pay for the damage on your car, that's going to be collision coverage if you've been in an accident. Okay. Now, if there's another reason besides an accident, like your car is damaged because of fire, theft, or falling objects, that's comprehensive coverage. So you might just want to review some of those terms. Okay, so let's look at this statement. The interest on a car loan can be determined by taking the difference between the total of all monthly payments and the amount of the loan. So what you do is you total all of the monthly payments over all the years. So if it was $500 a month for 5 years, right, you would go, okay, 5 times 12 is 60 times 500, you would get a value of 3,000 or something like that. Well, 30,000, sorry. All right, so you have that value there. And then you compare that to the amount of the loan. So if it was initially $25,000, you've paid $5,000 in interest. Okay, so this statement is true. You add up all of the monthly payments and you compare that to the initial amount of the loan to see how much interest has been accrued over the course of that loan. So it's basically the total you pay compared to the original amount that you took out. Okay. When an open-end lease terminates and the car's appraised value is less than the residual value, you owe nothing. This is not true. So when an open-end lease terminates and the car's appraised value is less than the residual value, you owe the difference. So basically, the residual value is an estimation that they're counting on there. If you turn it in and it's been damaged or something like that, it's not worth what it's supposed to be at the end of the loan. In an open-end lease, you have to pay the difference there. That's why I really don't like leases. I recommend you always buy a car, because then at least you have something at the end of it and you don't have a car payment and you still have a car. Okay, when an open lease terminates and the car's appraised value is less than the residual value stated in the lease, you owe nothing. It's pretty much the same exact thing as the previous problem. Right? You owe the difference if it's appraised at less. So this is identical to the previous problem. Okay. One advantage to leasing cars that you're not responsible. That's not true. You still have to pay for maintenance. You still have to pay for damage to the car. You don't own the car. So the one advantage is that there's only a small down payment or no down payment at all. Okay, this is the hard one where you've got to plug it in. I honestly recommend the payment calculator, but just be precise. You borrow $16,000 for 4 years at 6% toward the purchase of a car. All right, monthly payments. So we have everything we need. P is $16,000. You plug it in there. R is 0.06. N, it's monthly. 12. N is 12. Okay, so we've got at the bottom 1 minus 1 plus 0.06 divided by 12. And then we've got this to the power of. When you plug it in, it's negative 12 times the number of years, which is 4. Negative 12 times 4 is 48. So this will be going to a negative 48th power, so you should definitely plug this in a calculator. This will be a fraction. 0.06 divided by 12 is going to be like 0.005 or something like that when you put it in the calculator. So you have like 1 point, So you do the decimal, you raise it to the negative 48th power, you use 1 minus that, and so that will be your monthly payment, okay? Your monthly payment there. Now, monthly payment then is $375.76. How on earth do you figure out the total interest for the loan? From this point, right, you have to take $16,000, okay? So $16,000 was the principal, okay? So let me just go here. $16,000 was the principal amount. We know that there were 48 months and that we figured out the monthly payment from this equation was $375.76. So we take $375.76 and we multiply it by 48 because there's 48 monthly payments, right? It's 4 years, there's 12 months in a year. And we're going to subtract $16,000 from that value. So the total amount you pay would be the monthly payment times 48 over 4 years, right? You subtract the principal to find out the total interest amount is $2,036.48, which means the total of all those monthly payments was $18,036.48. Now, notice what it says, round to the nearest cent. In some of these, it says round up to the nearest cent. This one, you can round down if it's less, and that will give you a wrong answer. So pay attention to whether it says rounding up or rounding down when you do this. And then this last one is exactly the same thing. You've got to plug it in there. There's a new car that costs $25,000 that can be financed with a 3-year loan at 6.44. So on a scientific calculator or in this, right? Loan amount, loan term, interest rate. That'll calculate it if you put it in there. You put P, 25,000. R, 0.0644. N, always going to be 12 times a year with this monthly payments for cars. Then same thing, R, 0.0644. N is 12 to the negative 12 times what? In this case, 3, because it's a 3-year loan. So we need T to be 3. In the second one, same thing. You're plugging P in as 17,000. The rate is 0.0647, but the T needs to be 5. When you subtract those two things, you're going to find the difference in the monthly payment is $433.15. So it's a matter of plugging and chugging, but if you don't put them in right, it can be a little bit confusing as well. All right, so in this one, there were several equations that you needed to know. Okay, the simple interest one, I equals PRT. The future value of a loan, A equals P times 1 plus RT. Now, that is for a set time of accruing interest. Compound interest is different. You need to factor in how often the interest is compounded. So N would be the number of times that it's compounded there, right? So you're left with that equation at the start, right? That A equals P times 1 plus R over N and T, which is easier to do with the calculator. Remember, T is in terms of years, but if it says continuous interest, you have to put it in A equals P times E to the RT, where E is just a function on your calculator, right? And then finally, this payment equation, right? PMT is the payment, so you might just want to look at that and study it. I'm not sure if you need to memorize it, but you might as well. All right. So hopefully that will be most of the things that you're going to be dealing with interest here. If you have any questions, please let me know.